We are now in the Peszéri-erdő, central Hungary. This 1,600 hectare forest steppe habitat complex is a part of the European Natura 2000 network. Several protected species and habitat types occur here. Many are considered to be endemic to the Pannonian biogeographical region. This area includes fragments of sand-adapted varieties of Euro-Siberian steppe woods with quercus species, which habitat types has been almost completely eliminated during the last 3 centuries in Hungary. Besides the tree of heaven, Peszéri-erdő is threatened by other invasive species such as the common hackberry, the black cherry, and the box elder.
The tree of heaven, Ailanthus Altissima, is a native tree species to China and North Vietnam, where it is a frequent component of broadleaf forests. However, during the last 3 centuries, it has successfully colonized many different types of habitats, from temperate to meridional zones in all of the continents, except Antarctica. After its first introduction in the middle of the 18th century in Paris, it had become soon a popular exotic tree for several purposes in Europe. In Hungary, it had been widely used in forestry, gardening, urban development and agriculture. By now, it has become a common tree species in the country, but also clearly unwanted in almost every sector, including nature conservation and forestry. Ailanthus Altissima is a prolific seeder. One middle-aged individual can reach a few million seeds per year capacity. Its fruits, called samaras, could fly away from the mother tree or carried for hundreds of meters by the wind. These individuals here have already released the majority of their annual seed production, however they still have a few thousands for the early spring period. Ailanthus Altissima can reproduce from root suckerings and it can massively sprout from the stumps as well. Stump deposits are commonly made during the artificial reforestation progresses in Hungary. This means that after stumping, the stumps are stacked together in lines and just left on the field. Ailanthus Altissima can easily regenerate from the root remnants and stumps also diploid in these objects. The first mention of Ailanthus Altissima is from the 1930s in the Peszéri-erdő. But in the forestry inventory data, it appears only from 1971. Then we can clearly see its moderate invasion in the area until the millennium, when its population exploded. To identify if certain silvicultural practices might have had, and still have, significant impacts on the spread of Ailanthus Altissima, we aimed, first, to investigate the changes in the prevalence and abundance of Ailanthus Altissima following basic design in forest stands where selective thinning or clear cutting was implemented or there was no intervention. Second, to compare the scale of invasion of Ailanthus Altissima in artificial reforestations of different ages where stump deposits were made. Third, to evaluate the role of stump deposits in the spread of Ailanthus Altissima via abundance distance measurements. We applied full cover mapping to follow the changes in the prevalences and abundances of Ailanthus Altissima due to selective thinnings and clear cuttings followed by natural reforestation. The baseline conditions were recorded before, the remappings took place at least one vegetation period after the forestry interventions. We also used full cover mapping to compare the abundances of Ailanthus Altissima in artificial reforestations regarding the stand age. Finally, we used the transect methodology, including the stump deposit and the surroundings, to follow the spread of Ailanthus Altissima starts from the stump deposit. Our results showed that the investigated silvicultural practices do significantly facilitate the spread of Ailanthus Altissima. The selective thinnings and clear cuttings often led to a spectacular population explosion. In some areas, the abundances increased by 2 orders of magnitude. From the linear stump deposits in the artificial reforestations, Ailanthus Altissima could regenerate only in a few years. Over 10 years, the three species could already dominate the whole stand. During the progress of artificial reforestation, almost every living plant gets destroyed, plus also the germinable seeds are buried into deeper soil layers. However, if the stump deposits of Ailanthus Altissima are left in these areas, soon the three species will invade the young and intact stands. After a few years, the sprouted individuals will start seed production as well. That inevitably leads to a rapid spread within the stand and also in the surroundings.
Effective management of Ailanthus Altissima is surely a challenging task, but truly not an impossible one. In the OAKEYLIFE project, our conservation actions are based on previously implemented detailed full field surveys. Based on reliable, spatially explicit data, the identified monodominant stands of Ailanthus Altissima are cut down, and following complete site preparation, these patches are artificially reforested with native tree species. This solution is the most cost-efficient, as in a coppicing forest, clear-cutting is always followed by massive seed germination and sprouting of Ailanthus Altissima. In the case of forest stands with high conservation value, we apply selective chemical methods. Adaptively applying these methods, we are able to implement effective control of invasive tree species, reducing their populations by orders of magnitude. To prevent their recovery, some changes are necessary in forest management. Many of the most numerous Ailanthus stands are located on disturbed soil surfaces, mainly on stump deposits. To prevent the reinfection of forest stands by Ailanthus, stump deposits are recultivated and finally reforested by native tree species. Also, making new permanent stump deposits is not allowed anymore. All in all, we can effectively contribute to long-term sustenance of species-rich lowland forests, such as the sand-adapted Euro-Siberian steppe woods with quercus species.